Hi, I'm David Edmonds of the BBC World Service, and this is The Big Idea. I found the most fascinating ideas around and the people who thought them up, and I'm going to do my best to explain them. Let me take you back to one of the terrible episodes of World War II, what was known as the Hunger Winter. In the winter of 1944, the Nazis imposed a blockade on parts of the Netherlands. Over 20,000 died of starvation. Millions suffered malnourishment. But it's what happened next that suggests we have to change our view of what it is to evolve as a species. Today's big idea: epigenetics. Might what happens to you and how you behave have a biological impact on your children? At the forefront of establishing epigenetics as a big idea is Ewa Jablonka. When Polish-born Jablonka first began to air her views, she faced condescension and hostility. After moving to Israel as a child, she had gone on to become a geneticist. And now she was challenging the establishment.
Well, in the beginning it was really tough. I gave a talk in Israel, and there were people sitting there in the audience, and they were sort of nodding their heads from one side to the other. I was young. And they were saying, like, no, cannot be, and then getting up and leaving slowly the room. I mean, it was very difficult to cope with it.
Ewa continues to upset some fellow scientists. But to understand how, we have to travel back further in time. How did humans evolve? How did they change, adapt? Back in the 19th century, there was a dispute between two naturalists, one English, the other French. The Englishman Charles Darwin said that if tall giraffes had an advantage over short giraffes, say because they could reach the higher leaves in a tree, then they were more likely to survive and reproduce. Giraffes became tall through natural selection. The Frenchman Jean-Baptiste Lamarck had earlier proposed a different evolutionary mechanism.
Why do you have strong arms and I'm very weak? Why are your eyes blue and my eyes are dark? He believed that what happened in the history of your ancestors, how they lived, what they did, had an effect on how these traits developed in their own life, and the traits that developed in their own life had some heritable effect.
Lamarck believed, in other words, that if a giraffe stretched its neck to reach food, its children would have longer necks. His idea didn't survive. The arrival of modern genetics in the late 19th century appeared to kill it off for good. Our traits, we now understood, were transmitted through genes.
What is there in the sperm and egg, which was called the genotype, the genes, is not affected by what happened to the body that harbored this genotypes in the past, in the parent, in the grandparent, and so on.
What you did with your body was irrelevant. The body carried the genes, but did not affect them. At least by the mid-20th century, the Darwinian picture, buttressed by the science of genetics, had become orthodoxy. And it stayed that way until a few pioneers, including Ewa Jablonka and her collaborator Marion Lamb, began to investigate what is known as epigenetics. Epigenetics is the study of changes which are inheritable and which do not occur as a result of any change in our gene sequencing.
When we're thinking about epigenetics, we are thinking about the network of interactions that is the interface between the genotype, the genes, and the actual trait that we see. There are a lot of processes that are leading to the development of your nose or the shape of your ears. Epigenetics is studying these processes and the way that the genetic material is sort of organized, not changed in the sense of the DNA sequence, but organized in chromosomes. And it is studying also whether or not some aspects of this network are also transmitted to the next generation so that the developmental dispositions can be inherited.
So it's the study of how the genes interact with all these other processes.
And how this interaction can lead to some inheritance.
There is now a growing body of evidence that traits can be inherited through non-genetic processes. Some of it comes from plants. Some of it, rather bizarrely, from causing emotional trauma to mice.
So, for example, you take a mother mouse who has just given birth to a litter of little mice. And let us look at the males. What we're doing is we're stressing the young mice during the first 14 days after birth. We're taking the mother away from the little ones for 3 hours a day. They have all the milk they need, they have all the food and all whatever, but it is enormously stressful for them and for her. And while she's away from them, we also stress her so that she's forced to swim. They hate swimming. She's forced to swim in some little pool or something like that, and then you bring her back. And of course what happens is that the mice become slightly neurotic, which is not very surprising. If somebody did that to you, this would be probably a very similar result. What is interesting is now you take the males who are a bit neurotic, you mate them with a female who is completely normal, and you look at their children. And what do you see? They too are neurotic. And then you take them, the next generation, and you mate them again. And they are still neurotic.
So you can observe neurosis being transmitted through the generations. How many generations are we talking about?
3.
By stressing the great-grandfather, you can produce an effect on the great-grandson and the great-granddaughter.
That's right.
That's mice. But what about creatures who are a little more complex? Humans.
The starved, rickets-ridden bodies of this Dutch family are witnesses to the treatment of the...
In that Dutch famine at the end of World War II, the hunger winter, rations were reduced to 400 calories a day, the equivalent of 4 slices of bread per person. Using the detailed Dutch health records, researchers have been able to show that children born around this period suffered disproportionately in later life from a variety of health problems. And there's some weaker evidence that their children did too.
People are also studying Holocaust survivors, their children, and they are seeing that, for example, in the offspring of Holocaust survivors, the tendency to develop post-traumatic stress disorder is greater than in offspring of people who did not undergo this stress. And it seems that it cannot be explained just by nurture, by the fact that these people were born to people who went through the horrible trauma and had behaviors which affected their children.
The idea of epigenetics is still controversial, in part because of continued debates over evolution. In the US, 2 in every 5 Americans believe God created man in his current form. Although epigenetics has nothing to do with creationism, when Eva Jablonka began to promote it, she faced hostility from fellow biologists.
People thought that people who promote the kind of ideas that I'm promoting are either stupid, ignorant, megalomanic, or all these things together.
Slowly, the idea that epigenetic processes affect future generations is becoming the new orthodoxy. And if Eva Jablonka is right, then things that happen to you in your lifetime could affect descendants you may never meet. Thanks a lot for listening to The Big Idea from the BBC World Service with me, David Edmonds. The producer is Ben Cooper. If you think this episode should be passed down to your children and grandchildren, please leave a rating or comment if your podcast provider allows you to. You can even let me know on social media about the big ideas you think I should be looking at. In episode 4, how big data can predict the success of a city. Thanks for listening.